Alright, hi year 11s, this is Mr. Lim here again, and this is our 12th video on hydrocarbons on addition reactions, the first of them. Alright, so let's get started. Okay, so we're going to be learning about addition reactions, what are they, and how do they work. Right, so let's go on, let's have a look. Okay, so alkenes and alkynes, which is our unsaturated hydrocarbons with their double bond and triple bonds, can have their double bond and triple bond broken and substances added to the carbons that were part of the double and triple bond. All right, you can add hydrogens, halogens, water, and hydrogen halides to these double bonds. In this video, we're just going to be covering the hydrogens and the halogens. All right, so when a substance is added, so that's the hydrogen, halogens, water, or hydrogen halides, there is no other product, okay, other than the hydrocarbon based product, because the added molecule is split and both parts are added to the hydrocarbon. So this is different to the substitution reactions, where the substitution reactions produces a hydrogen halide as another product, whereas this one here, the addition reaction, you're taking both parts of the halogen or the hydrogen or something and then adding it to the hydrocarbon so that there's no other product left. Okay, let's go on. Addition reactions of halogens can occur in the absence or presence of UV light and is spontaneous at room temperature. So this is a way to differentiate between saturated hydrocarbons, which will only undergo substitution reactions, and unsaturated hydrocarbons, which will undergo addition reactions, and they'll do so depending on the presence of UV light. Okay, because they'll both. So what will happen is effectively the halogen looks a certain way. When it reacts, it will change its appearance. And so for an alkane, in the absence of UV light, that appearance won't change. And for an alkene, in the absence of UV light, the appearance will change. Right? So therefore, that you can use that property to distinguish between an alkane and an alkene that look exactly the same, but then react differently. Okay? The amount of the addition of the hydrogen requires significant amounts of energy and does not occur at room temperature. So this one here was talking about halogens. This one's talking about hydrogens here. All right. So one of them occurs easily with you, even in the absence of UV light. One of them does not occur easily. All right. So let's just go walk through kind of what happens. Here I have, what do I have? I'm gonna have a bit of propene here. All right. Do I need to give it a 1 propene? No, because there's only one place the double bond can go, and it'll be across the 1 and 2 carbons. All right, so there's 1, 2, 3, 4, 5, 6 hydrogens here. All right, and then I'm going to add it to Cl2. All right, so what happens is that the double bond breaks. So this double bond here breaks and turns into a single bond. And so now you just have a single bond where there was a double bond, a single bond now where there was a double bond. And now you have 1, 2, and now you have 2 extra bonding positions there which weren't there before. And those 2 extra bonding positions will be taken up by the chlorines there. All right, so what you've effectively done is you've added the 2 chlorines onto the hydrocarbon and you've formed 1,2-dichloropropane, in that. Right, and you won't require any UV light. This will occur spontaneously in at room temperature. All right, so that's what happens there. Okay, cool. So when hydrogens are added, an alkane is formed. So let's have a look. So if I go, let's do 2-butane, right, plus some hydrogen gas, that double bond is going to break and form a single bond instead. So that's this single bond here, which was there as the double bond. All right, and then I'm just going to draw out these to show you how many were there in the first place. Let's move that arrow, and I ran out of room going sideways. I probably should have gone sideways, but it doesn't matter. Right, so you're going to have the 2 hydrogens added onto the two bonds that were formed, right? But because you're adding hydrogens to something that has hydrogens already, it's not going to look very different. It's just going to form butane. Okay, so 2-butene plus hydrogen, the addition reaction will form butane. All right, so that's when hydrogens are added, you'll just form an alkane. All right, but when a halogen is added, so now let's go take away these ones here and instead add a halogen, such as Br2, all right? The Brs will be attached to those two carbons, right? So effectively, wherever the double bond was across those two carbons, that's where the Br will go, right? And so they'll be adjacent to each other. So this is 2,3 dibromobutane. Okay, it also forms an alkane as well, but it's an alkyl halide. All right. So what you then because the real point of this is the idea that you are not going to produce something like this, where you've got bromines over here and bromines over there. You can't have the bromines not adjacent to each other after an addition reaction. All right. They've got to be adjacent to each other wherever the double bond was. Okay. So if I show you this, you should be able to say that, okay, well, if this is the product of an addition reaction, there must have been a double bond here prior to the reaction. And if there was a double bond there, it would look like this. And you could name that as 1-pentene. All right. So that's the idea of addition reactions when you add a hydrogen or a halogen, so H2 or the diatomic halogens. Then you're going to have the two things attached across the double bond. And then our next video will go through what happens if you put a hydrogen halide, or a water in there. Okay, that's it. Adios.